Hi, this is Amy from the Alti store. I wanted to take a minute to talk to you about the Panasonic HIT modules. Now, those of you who have been in the industry for a while might remember them as the Sanyos. Same technology has really moved forward a lot, and it is now owned by Panasonic. Now, they are a higher voltage panel. They're 96 cells instead of the standard 60 cells that we tend to see in grid-tied, or even 72 cells that are used more for bigger commercial systems or 24-volt panels. These 96 cells, they're perfect for using with the SolarEdge 400-watt DC optimizer, or you can use the SolarEdge 700-watt optimizer with 2 panels and 1 optimizer. Really, really nice, perfect solution for that. They've got a much higher open circuit voltage than the 60-cell panels. They're at 69.7 volts. They have a lower short circuit current, so 6.07 amps. Now that's a nice thing because with the higher voltage and the lower current, if you are going long distances with a DC, you're actually going to have lower voltage drop. So really nice advantage of having the higher voltage. These are available in a variety of wattages. The one that I'm showing here is a 330 watt panel, and it's really got a very, very high conversion efficiency. It's an ultra efficient panel. The panel has got a few different things going for it to make it unique. It has a unique structure. It's heterojunction. So what it has is it has the monocrystalline and the amorphous, and they're different layers. So you get different benefits from different technologies, and the amorphous silicon on the outside layer actually helps reduce surface loss and allows for more electron flow. And as a result, it's actually a bit more tolerant of partial shade. So just pure mono panels, they're really not crazy about having any shade, but with the amorphous layer, it will take some. Now, I'm not saying that these are going to work in the complete shade, but they are a bit more shade tolerant. Also, if you've got less than perfect angles, it really does help capture more of the energy from the sun. So another thing they've done is the surface of the glass. It's actually got a pyramidical surface, so it's going to reduce reflections and really capture more light. It also has an anti-reflection glass so that, again, the light isn't bouncing off it. It's going to be absorbing more of the energy from the sun. Now, it does have this clever little rainwater drainage capability here. So when it does rain and the water is going to be dripping off here, you're not going to get buildup of dirt and water spotting. It's really going to drain off quite a bit better. So that just, all these little things, they just really start to add up. Now, I've said that these are really very efficient. So let me show you this 330 watt panel compared to another brand 300 watt panel. So I've now got the 2 panels stacked on each other so that you can compare the size. This is a fairly standard 60 cell panel that is really the standard efficiency, and it's 300 watts. So you can see it's a little bit taller and more narrow, whereas the Panasonic is wider and shorter. So as far as square footage, they're both practically the same, right about 18 square feet. So with the higher efficiency, we've actually, with the Panasonic, we've got 18.3 watts per square foot, as opposed to 16.6 watts per square foot for this 60 cell panel. So that gives you a 1.7 watt difference per square foot. Now, if you start adding that up across your array, that's going to be a significant difference. So you're going to be able to get a much bigger array on your roof with the Panasonic. So another great feature with the Panasonic HIT modules is they've got a better heat tolerance. So as you can imagine, it's going to be pretty darn hot on your roof up in the summertime. Now, solar panels are rated at standard test conditions, which is 25 degrees Celsius or about 77 degrees Fahrenheit. Well, I don't need to tell you that it gets a lot hotter than that in the summer up on a roof. So if you can have a panel that can handle the heat better than another, over the life of that system, you're going to get a lot more power and a lot more accumulated energy out of that panel. So, for example, the Panasonic HIT module, it has a temperature coefficient of minus 0.30% per degree C. So that power is going to go down 0.30% for every degree above 25 degrees Celsius. Now that example we're doing, that's 25 degrees above. So that is going to be the 0.30% times the power times 25. So that ends up losing 24.75 watts per panel if you've got really hot temperatures. So now, with a standard 60-cell panel, a typical temperature compensation is actually minus 0.41% per C. So again, if we were to compare apples to apples and the same wattages, that's going to be losing 33.75 watts per panels. So now if we start doing the adding this up, if we've got an array of 20 panels, with the Panasonic we would lose 495 watts, but with the other panel you would lose 675 watts. So that's a 180 watt difference just from the temperature. So again, this starts to add up. So we've got a more efficient panel so you can fit more wattage in a smaller space, and you've got the ability to work better in less than perfect light conditions, less than perfect angles, and it's going to be producing more power when it's hot. So all of this ends up with a tremendously more efficient and greater output of your array over the life of your system. And speaking of life of the system, it has got a 25-year workmanship and power output warranty. That's just unheard of, that they're going to be guaranteeing both the workmanship and the power output for 25 years. And you know that these will continue working well after that 25 years. So you're really guaranteed a very long life, very high output from these Panasonic HIT modules. I hope this was helpful. If so, give us a like and a share, and be sure to subscribe to our AltiStore channel so it'll notify you when we've got new videos coming out. And don't forget to go to our website at altistore.com, where we've been making renewable doable since 1999.